let's compute probabilities with permutations and combinations. So this is some exciting stuff we're dealing with. So let's remember that probability is what we want to happen, right? The number of that, what we want, over your total possibilities. And that's in general, okay? So what we want on the top, total possibilities on the bottom. Permutations mean that order matters, right? We're arranging things in an order, and the order does matter. And then a combination, the order does not matter. We don't care what order it is. It just needs to be there. All right, let's jump in. In the last track and field championships, 10 runners made it to the final heat. What is the probability you correctly pick the top 3 finishers? Okay, now let's think about this. We have 10 total runners. We care about the top 3. Does it matter what order they're in? The answer to that is yes. And therefore, we have a permutation. Okay, so we've got to think about this. I want a permutation, and I care about the top 3. So what I want to know is 10p3, right? That's the probability of the top 3 finishers. Now, on the bottom, right, these are the total possibilities. Well, the total possibilities is 10 factorial, because this is everybody. Okay, so what we are dealing and what we want is 10p3, right? This gives us the total number of top 3 finishers. Okay, so if I know 10p3, this is how many top 3 finishers there's going to be. Now, if you're picking this, you pick one of them, right? So we are going to have 1 over 10p3, because this is what we want to have happen. We want to pick the winning one, the top 3. And this is the total number of top 3 finishers that there could be. So we've got to find 10p3. So let's remember, 10p3 can be found by taking 10 times 9 times 8, right? The shortcut is you start with 10 factorial, but you only use 3 numbers, 10 times 9 times 8. And that gives us 720. So our probability is 1 out of 720. If I change that to a decimal, I get 0.0014. So there's about a 0.14% chance that I can actually, 0.14% chance that I'm going to pick the top 3 finishers. That's all 3. Okay? All right. You are choosing 3 writing utensils from a box that contains 5 pencils, 8 pens, and 12 highlighters. What is the probability you choose 3 pens? All right. Do we care about the order? No, we just want 3 pens. So this is a combination. All right, now think about how many different ways, right? This is letter A here. We're going to do a couple of these. But how many different ways can we choose 3 items, right? 3 items total. If I do 25C3, because 5 plus 8 plus 12 is 25. So I know there are 25 total items. I'm choosing 3 of them. These are the total options. How many total options of things can I get? And we want to know, out of the 8 pens, how many different ways can we choose? Oops, why did I put a P? How many different ways can I choose 3 of them? So this is what I want. Out of 8, I want to choose 3 of them. And I don't care which 3, I just need 3 of them. So in the numerator, we're going to take 8 times 7 times 6 over 3 times 2 times 1. And in the denominator, I'm going to do 25 times 24 times 23 over 3 times 2 times 1. Because remember, with combinations, we do the same thing where we start with 8, think factorial, but only use 3 numbers, 8 times 7 times 6, and then we divide by the r factorial. Now, in the top, 3 goes into 6 twice, 2 goes into 2 once. I'm left with just 8 times 7. And in the denominator, 3 goes into 24 8 times, and 2 goes into 8 4 times. So I'm left with 25 times 4 times 23. So when I do that, now I have 56. 8 times 7 is 56. And 25 times 4 times 23 is 2,300. So I can divide that out, and I get 0.0243. So I have a 2.43% chance of grabbing 3 pens when I pull out 3 items here. All right, let's do another one. We're using the same 25 items, okay? What is the probability you choose 1 pen, 1 pencil, and a highlighter? Doesn't matter what order, just these 3. So again, our denominator is 25C3, which we know is 2300, actually. That was what it was back here, right? Okay. Okay, now, in the top, we want out of 5 pencils, we want 1. Out of 8 pens, we want 1. And out of 12 highlighters, we want 1. So 5 choose 1 is 5, 8 choose 1 is 8, and 12 choose 1 is 12, all over 2300. So 5 times 8 times 12 gives me 480, divided by 2300, and we end up with 0.2087. So roughly a 20.87% chance of grabbing 1 of each. And that's computing probability involving permutations and combinations.